All right, let me get this another interval here. It's a nice problem from the book. This is, I think, my third attempt to record it because I keep drawing it slightly wrong and ran out of space on one. But we're going to look at function over the s and t plane where it's e to the s natural log of t. And so it's bounded in the s and t plane by s. E equals the natural log of t. And t will be bounded between t equals 1 and t equals 2. So I'll draw my s and t plane boundaries. To make this easier for me to draw, I'm going to make this my s-axis and this my t-axis. That means the natural log function starts at 0 when t equals 1 and 1 when t equals 2. So natural log goes like this. So there's s equals natural log of t as one part of my boundary. Then my other part of my boundary is t equals 2. And t equals 1 just traps down this lower side, letting us realize that that is our region that we are integrating over. So this is our region of interest. All right, so we can start building our integral now. And I think what we want to recognize is if I integrate parallel to s, if I'm coming from here to s, then in this axis, the t-axis, means that s is going to go from 0 to the natural log of t. And that means that I'm going to be integrating from t from 1 to 2. Because the boundaries on t here. So that's e to the s natural log of t. ds dt is the order of integration that we're doing this in. So if I evaluate this with respect to s, then in e to the s becomes e to the s natural log of t, and I need to look at it when s equals 0 and s equals natural log of t. So that's going to give me e to the natural log of t minus e to the 0 natural log of t dt. And that comes out to t natural log of t dt, natural log of t minus natural log of t dt. And now we're going to play some games with integration by parts. Now, if we looked at natural log of t was an example in the textbook from Calc 2 for integration by parts, but I'll redo it over here. What I'll do is I'll do this part, and then in this part is integration by parts. So I'll start with this in blue. So I'll say that u will equal natural log of t, and u prime will equal 1 over t. That means v prime was 1, and v came from t. So u times v is t natural log of t, minus the integral of v du, or t times 1 over t dt. And so t ln t, well, that's going to be 1 or minus t. So the second part of this is t ln t minus t. And now let's look at the first part as our integral in red. And I'm going to do this in red. So I'm going to keep a u over here, ln t. U prime is 1 over t. That means v prime is t, and v is t squared over 2. So that means u times v is t squared over 2 natural log of t minus v du, or t over 2 dt. So that's going to give us t squared over 2 ln t minus t squared to the fourth. So now I can put this all together, and I'm going to get t squared, whoops, keep this in yellow, t squared over 2 ln t minus t squared over 4 minus t ln t plus t, right, minus this. All evaluated from 1 to 2, so that's going to give me 2 squared over 2, or 2 natural log of 2, minus 2 squared over 4, which is 1, minus 2 natural log of 2, plus 2, so that was the top. And now I'm going to subtract minus 1 squared over 2 times natural log of t, which is 0, so that term goes away. Minus a minus, so that's plus 1/4. Minus a minus, that's plus 1 times natural log. But 1 times natural log of 1 is also 0, so that goes away. And so minus 1. And if I look at my terms here really quickly, I have a negative 1 and a negative 1, that's negative 2. A positive 2, that goes to 0. A 2 natural log of 2 and a negative 2 natural log of 2, they go to 0. And the only thing left is 1/4.